Background radiation is low levels of radiation from environmental sources always present around us. Examples of these could be nuclear power and weapons, cosmic rays, food and drink, medical, ground and buildings, and radon gas. Alpha particles are composed of 2 protons and 2 neutrons, the same as a helium nucleus. Inside the body, it is highly ionizing and very dangerous, and can cause radiation poisoning and cancer. Outside of the body, it is absorbed by a surface layer of dead skin cells, so there is no danger. A beta particle is an electron emitted at high speed from the nucleus when a neutron decays into a proton. Moderate ionization and danger is found inside the body, and exposure should be minimized. Outside the body, there is moderate ionization and danger. Close exposure should be minimized. Gamma rays are high energy, high frequency electromagnetic radiation emitted from a nuclear radioactive decay. Inside the body, there is minimal ionization, but still there is a danger of cancer from long-term exposure. This is the same outside the body. Activity is the number of radioactive decays in a unit time. A decay constant, lambda, is the probability per second that a given nucleus will decay. Combining the 2 equations, A equals dN by dt and A equals negative lambda n, gives dN by dt equals minus lambda n. The solution to this differential equation is n equals n0 e to the minus lambda t, where NO equals initial number of nuclei, T equals time that has passed, and N equals number of nuclei remaining at time t. The exponential term is the fraction remaining at time t. Half-life is the time taken for half of the atoms of a nuclide within a sample to decay. Alternatively, the time taken for the activity of a sample of a radioactive nuclide to reduce it to half its initial value. Nuclear binding energy is the energy used to hold the nucleus together, converted from the mass deficit following E equals mc squared. Nuclear fusion happens when small nuclides combine together to make larger nuclei, releasing energy. The proton-proton nuclear fusion reaction, typical in small cool stars such as our Sun, where the core temperature is 15 times 10 to the 6th Kelvin. Nuclear fission happens when larger nuclei are broken up into smaller nuclides, releasing energy. Uranium-235 can absorb slow-moving neutrons to become the unstable isotope U-236.